Good morning all of you. Hope all of you are safe at your home. This video is basically continuation of my previously taught video. In this video we will discuss last topic of chapter 3, that is mole concept and numerical. So let's just start. Basically mole concept of a substance is the amount of the substance which contain the same number of particles that are present in carbon 12 atom. Means if we take one atom of carbon 12, so the atomic mass of carbon 12 is 12U, and when we convert them into a gram atomic mass, then we used to write down 12 gram. So basically that 12 gram is made up of some number of particles. So the collective counting of these number of the particles which involve in the formation of 12 gram of carbons are measured by one unit, that is called as mole. First time mole concept was discussed by William Ostwald. What exactly he described, that he said that if we take example of 1 dozen of banana, so 1 dozen of banana is get formed when 12 bananas get combined together. So 12 bananas get collectively combined, then only the 1 dozen banana get formed. So 1 dozen is the bigger unit in comparison to the 12 bananas. So similarly mole is a one counting unit, in that we used to measure the approx number of the particles how any chemical compounds are get formed. So we can say that, and any chemical compound is approximately made up of some number of particles which was first discovered by Emilio Avogadro. That number was also called as Avogadro number, and that number is 6.022 into 10 to the power 23. I already told you that this number is also called as Avogadro number or Avogadro constant. It is an approximate value, and according to that, if we take 1 mole of any atom, any molecule or any ion, that atom, molecules or ion are approximately made up of this much number of the particles. So and another thing which were described in order to explain mole concept, it was said that 1 mole of any atoms, molecules or ions are exactly equal to their gram atomic mass, gram molecular mass. If we take any atom, then we take gram atomic mass, and if we take any molecule, then we take gram molecular mass. So we can say that it represents the definite number of particles which is exactly equal to 6.022 into 10 to the power 23. Second, it represents a definite mass of a substance equal to the gram atomic mass of element or gram molecular mass of a compound, that we already discussed. Now, what exactly the gram atomic mass of an element? When we express atomic mass of any element in gram, then it is known as gram atomic mass. Similarly, what is molecular mass? Basically, first you have to understand how to calculate molecular mass. Molecular mass is exactly the sum of the atomic masses of the number of atoms present or involved in the formation of any molecules. So the combined result is known as a molecular mass, and when we represent that mass in gram, then it is known as gram atomic mass. So the relationship between the moles mass, molar mass, the number of atoms or molecules and Avogadro number is basically N is represented by mole. Mole is equals to given mass upon gram atomic mass or gram molecular mass. Means in order to find out the number of moles, we apply this formula which indicate mole is equal to given mass upon molecular mass, or we can say that a gram molecular mass or gram atomic mass. Similarly, in order to find out the number of particles or number of atoms, mole is equals to given molecule upon Avogadro number. By this, we are able to calculate the number of particles involved in any chemical compound. Related with this, one more concept is there, that is molar volume. What is molar volume? In simple language, we can say that molar volume is the volume of 1 mole of any gas at STP. which is always coming equal to 22.4 liter. So whenever we used to measure volume of 1 mole of any gas, it always comes equal to 22.4 liter at STP. STP means standard temperature pressure. If we take example of water or any gas, suppose water. So water get boiled at 100 degrees centigrade. So when the temperature reaches up to 100 degrees centigrade, immediately the water start boiling. So up to that temperature, some amount of pressure is also there. So that is known as standard temperature pressure. So basically this indicate the molar volume is the volume of 1 mole of any gas at STP is always coming equal to 22.4 liter. Okay, that is known as a molar volume. The second concept is molar mass. What is molar mass and how to calculate the molar mass? In normal mathematical language, we can say that when we represent atomic mass or molecular mass of any chemical compound molecule in gram per mole, then it is known as molar mass. Or in chemical language, we can say that the mass of 1 mole is known as a molar mass. We can also define molar mass like this: when we divide gram atomic mass or gram molecular mass by 1 mole, then it is known as a molar mass. So suppose the molecular mass of gram molecular mass of H2O is gram molecular mass of H2O is coming 18 gram. So when we divide this 18 gram by 1 mole, then we will get 18 gram per mole. So this is known as a molar mass. So basically one difference is there. When we are talking about atomic mass or molecular mass, then the unit should be U. When we are talking about gram atomic mass or gram molecular mass, then the unit should be gram. And when we are talking about molar mass, then the unit should be gram per mole. That is the unit of molar mass. This is all about the mole concept. Now let's just see some numericals related with the mole concept. Just keep one thing in your mind, that whenever we are talking about 1 mole of any atom or molecule, it is always equal to their gram atomic mass and gram molecular mass. So let's just see some numericals related with mole concept. Starting with the first question, how many molecules of water are there in 54 gram of water molecule? So what exactly we will do? We will calculate the molar mass. 2 atoms of hydrogen is there and 1 atom of oxygen. So we will calculate, we will take the sum of the atomic masses of hydrogen molecule and oxygen atom. Then it will come 18 gram per mole. After that, we will find out the numbers of moles present in 54 gram of water molecule. Then formula, we know that N is equals to given mass upon gram molecular mass or molar mass. So given mass is equals to 54 and gram molecular mass or molar mass is 18. So it will come 3 mole. 1 mole is equals to 6.022 into 10 to the power 23 molecule. Then the 3 mole, so 3 into 6.022 into 10 to the power 23 molecule. So our answer will come 18.066 into 10 to the power 23 molecule. Now let's just see the second question. In the second question, you have to find out the mass of 12.044 into 10 to the power 23 oxygen atom. The mass of 1 mole of oxygen atom is 16 gram, which is equals to 6.022 into 10 to the power 23. 10 to the power 23 oxygen atom. So we can say that 6.022 into 10 to the power 23 oxygen atom is equals to 16 gram. Then 1 atom is equals to, it will come 16 upon 6.022 into 10 to the power 23 gram of oxygen atom. Then 12.022 into 10 to the power 23 atoms of oxygen is equals to how much gram? Then it get multiplied by this whole equation. So it will come 16 upon 6.022 into 10 to the power 23 multiplied by 12.022 0.044 into 10 to the power 23. So it will come like this. If you take like 12.044 into 10 to the power 23. So it will come to and 32 gram. Now let's just see some more example. Third question, calculate the number of copper atom present in 0.3175 gram of copper. So what exactly we will do? We will first find out the number of moles present in 0.3175 gram of copper. So how we will take? We will take that applying by formula, mole is equals to given mass upon gram atomic mass or gram molecular mass. So the value will come like this, 0.005 mole. After that we will calculate the number of atoms. 1 mole is equals to 6.022 into 10 to the power 23 atoms of copper. Then 0.005 mole is equals to how many number of atoms of copper atom. Then we will multiply calculated mole by 6.022 into 10 to the power 23 atoms of copper, and our answer will come 30.11 into 10 to the power 20 copper atom. Now likewise this some more example is there. Question number 4, calculate the mass of 0.5 mole of calcium carbonate in gram. So what exactly we will do? First we will calculate the molar mass, and after calculating it will come 100 gram. So 1 mole is equals to 100 gram. 1 mole is equals to 100 gram. So 0.5 mole is equals to how many gram? So we will divide by 100 gram by, we will multiply 100 gram by 0.5 mole by 100. So it will come 50 gram. Now question number 5, calculate the number of oxygen atom present in 0.2 mole of sodium carbonate decahydrate. Then what we will do? We will take out the mole of oxygen atom in 1 mole of decahydrated sodium carbonate. So here just see, look at this in this question, 3 atom of oxygen is there and here 10 atoms. So total number of oxygen atom present in this formula is 13. So mole of oxygen atom in 0.2 mole of sodium carbonate 10H2O, 0.2 into 13, it will come 2.6. So we will calculate the number of oxygen atom, 2.6 into 6.022 into 10 to the power 23 is equals to 1.55 into 10 to the power 24. So likewise this we are able to calculate our answer. Likewise this many more examples are there, many more numericals are there which is given in your side book. Try to solve it and we will do more numericals related with the mole concept, and by this your chapter is get over. Thank you.